All right, so we're going to talk about using classification trees to profile the types of classes that receive a lot of reviews. So since we have our reviews as a continuous variable, to start off, we needed a binary variable to do a classification tree. So what we decided to do was we decided to set a threshold that determined what constituted having a lot of reviews. And this is how we do it. We use the .describe function and just targeted the 75 percentage threshold, and so that ended up being 67 reviews. So this is our number for high reviews. If it was over this, this is what we constituted as a high review. And what we did was we created a new column called high reviews and set a number equal to 0 if it didn't meet this threshold, and set a number equal to 1 if it did meet this threshold. From here, we also created dummy variables for our subjects and level, and created a classification tree. And so this is our standard tree. And what you can see here is it's very heavily dependent on the number of subscribers is one thing that we initially noticed. We have one pure node here. It is 15 classes that didn't reach a high review threshold and 0 classes that didn't reach a high review threshold. You can see that the way that we get here is if the number of subscribers is less than 3,118, if it is the subscribers is more than 601 and a half, the content duration is less than 2.5, the number of lectures is greater than 35 and a half, and the subject is musical instruments. If the class fits that criteria, it will not receive a high number of reviews. On the other side, we have a near perfect node on the right. We have 619 so we have 69 classes that received a high number of reviews and one class that didn't out of 70. We get there by starting with the number of subscribers, which is greater than 3,118. We jump to the right and see that the number of subscribers is actually greater than 7,859 and a half. And then also an attribute to this is the number of lectures is greater than 57 and a half. And then that's how we get to our node of 69 classes being high reviews and one not being a high review. That's how we interpret this chart right here. This is our accuracy metric for the validation data, about 86%. Analyzing what we see, this is what we just kind of went over, how we get to some of these nodes, what they mean, how to interpret the tree. And so this is a correlation heat map. Since we noticed that the number of subscribers is highly influential in determining the number of reviews, we want to take a look at the correlation heat map to see if our suspicions were true, and we can see that the number of subscribers and the number of reviews are highly positively correlated. Um, so this isn't necessarily a bad thing, but if we wanted to profile what makes a class receive a lot of reviews, um, a lot of the aspects of that get overshadowed if we're just looking at number of subscribers, for example. So we're not able to accurately figure out what influences a class to have a lot of reviews aside from it just having more subscribers. So what we can do is there's two ways that we could go about this. We could normalize our review variable by the number of subscribers, just so we or we could remove the subscribers variable from our analysis completely and just look at the other variables. So what we wanted to do is we went ahead and we did both just to see and compare and see what we get. So we'll start with normalizing. When we normalize our number of reviews by the number of subscribers, we're seeing how many reviews each subscriber brings to a course. Um, by looking at our new classification tree, we're seeing what factors influence each individual to being more or less likely to leave a review, outside of just, sheer number of subscribers. So yeah, let's take a look. As you can see, this classification tree is a lot more diverse. It doesn't just start with two number of subscribers nodes. We have a few pure nodes in this tree, and we can kind of go over how we get to some of these to understand how to interpret this tree. So if a class has a content duration less than or equal to 4.5, um, go to left, and if the class is also not a web development class, and if the class is paid for, and the content duration is greater than 3.5, so between 3.5 and 4.5 for the content duration, and the number of lectures is greater than 84, we end up on this pure node here where all six of the courses out of six received a high number of reviews. On the other side, we can see that if the content duration is greater than 4.5, if the number of lectures is greater than 107, and if the price is less than 42.5, and it's a graphics design course, we can see that all four of those classes received a high number of reviews. So these kind of highlight some of the factors that lead to a course having a high number of reviews per subscriber. So it involves a lot more than just the subscriber count. This is our validation accuracy, which you can see is a lot less than our original model, but it allows us to look at some aspects of our model that we didn't see before. So, what we could also do is just remove subscribers from our from our model just to see what other aspects influence. We're not going to normalize any of our variables. We're just going to remove the subscribers variable and see what we can get. And this is our classification tree. You can see that it starts with if the course is a web development course or not. Um, if it is, well, we don't have any pure nodes to follow, but we can try to get to an almost pure node over here on the left, where 7 out of 8 are high review courses. So if it's not a web development course and it is not paid for, and it is an intermediate level course, we can see that 7 out of 8 are high review courses. And so, and this is the validation accuracy. This is a little bit higher than our validation accuracy for our normalized classification tree, which is around 73%. This one is around 79%. Still less than our original model, which was at around 86%, but a lot less dominated by the number of subscribers. So it is a little bit more useful in my opinion. And so this is how we decided to use classification trees to kind of profile what makes a course a high review course.